Hello class, welcome to the last part of the rules of differentiation. Remember that so far we have seen the rule of the product and well the rule of the sum too. So I made a mistake, maybe I should call this rule 3 and rule 4. Let's do that in order to keep consistency. 3 and 4. Okay, so we have the sum rule down and the product rule for differentiation. Now, rule number 3, what happens when we have a quotient of functions? Okay, suppose that you have a function h that can be written as the quotient of two functions. Okay, so what's going to be the derivative of h? Well, it's going to be all of this, and as you can see, it's even more complicated than the one for the product. But it's just a matter of memorization, really. So it's going to be the derivative of h is going to be the one below. Now I'm going to call this top and, or let's call them up and down or whatever. So the one below, the function that is below, times the derivative of the one on top minus the one on top times the derivative of the one below over the one below to the square. So you're gonna need to exercise your memory skills quite a lot in order to get this one down. Okay, in Spanish, the same. I'm gonna tell you the same that I told you when I referred to the rule of the product. I think the best way for you to learn this, since you're native Spanish speakers, is to memorize these formulas using Spanish. Most people in Mexico and Latin America memorize this rule in the following way. La de abajo, la derivada de un cociente de dos funciones es igual a la de abajo por la derivada de la de arriba menos la de arriba por la derivada de la de abajo entre la de abajo al cuadrado. Regresa el video un poquito, vuelve a escuchar lo que dije y cada vez que realices esta derivada de cociente, dilo de esa forma y pronto se te va a quedar memorizada. Okay, so that is my third rule, the rule of the quotient. Okay, and by far the most powerful rule, I think, in my opinion, is this one. This is known as the chain rule. The chain rule for differentiation. And what this rule says is that if you have a function h, which can be written as the composition of functions, I hope you remember that. And if you don't, go back and review that stuff, composition of functions. That's because that's going to be crucial to your understanding of this rule, composition of functions. Then the derivative of, if h can be written as f evaluated in another function, then h prime of x is going to be equal to f prime evaluated in g of x times g prime of x. I'm going to explain this in much more detail in a moment. Okay, I'm going to give you 4 examples of this, and I think only 2 examples of this will will be enough. But this one's the one that I really want you to understand, because this is by far the most powerful, and this one is the rule that's going to allow you to differentiate more complex functions. You're going to see what I mean in a moment. So let's start. So the quotient rule. Let's work on 2 examples. Number 1, I'm going to give you this function, h of x equals 2x squared plus 1 over cosine of x. So as I can see, h is basically can be understood as the quotient of two functions, one of which is this one and the other is this one. So I may call all of this, I may call it f of x. So f of x is going to be 2x squared plus 1, and all of this I may call g of x. The names are not important though. You can call whatever function whatever you want. So g of x is going to be cosine of x. So basically what I'm saying is that h of x is equal to the quotient of f of x over g of x. And whenever I can put a function in this way as a quotient of another two functions, I can apply the rule of the quotient and say that h prime of x is going to be the one below times the derivative of the one on top minus, there is a minus here, okay? If you change this for plus, the whole thing is wrong. So minus the one on top times the derivative of the one below over the one below to the square. Okay, now once you write the formula, go on and calculate the derivatives. If you already know f and if you already know g, go calculate their derivatives, right? Because all we need in here is, since we already know g, which is this, so I already have that stuff, and I already have this stuff, which is 2x squared plus 1. All I need now, and by the way, we already have this stuff. All we need now is to compute the derivative of f and to compute the derivative of g, and I'm done. So let's calculate the derivative of f. I'm going to do it directly now. You should be able to, I believe by now, do this quickly. F prime of x will be 4x. I'm done. And the derivative of g will be g prime of x, which is going to be minus sine of x, and I'm completely done. So once I do this independently, I go back to my main problem and I just paste these two solutions, right? So h prime of x is going to be g of x, which is cosine of x, times f prime of x, which is for x, minus f of x, which is 2x squared plus 1, times g prime of x, which is minus sine of x, over g of x to the square. So g of x is cosine of x, so I'm gonna get cosine of x to the square, and I'm done. You don't have to do anything else. If you arrive at this point, you are completely done. I mean, yeah, you can maybe simplify a little by, putting this coefficient at the beginning of this term, and then maybe multiply this minus times this minus, etc. Okay, you can simplify a little more, but technically speaking, you are done. You have already calculated the derivative of h, and whether it's simplified or not, that's a whole another matter. Okay, so this is done, and I recommend to you that you keep it this way, because the derivatives of quotients are already complicated, and trying to simplify these things, if there is no purpose for that, if there is no goal in that, just keep them this way. This is already perfect. Okay, so that's how it works. Let me give you another example. Number 2. Sorry. Let's write h of x is equal to minus 3x to the minus 2 minus x to the 3 over e to the x plus x squared. So this one is a little more complex, right, than the one before. So same idea. I can notice that h of x is actually the quotient of this, which can be understood, sorry, as a single function, and this other thing, which can be understood as another function. I may call this f, I may call this g. So let's do that. F of x is minus 3x to the minus 2 minus x to the 3. G of x will be e to the x plus x squared. Okay, and I go, let's do this directly. Okay, h prime of x will be the one below times the derivative of the one on top. And I'm gonna make use another time of the derivative operator. The one below times the derivative of the one on top, minus the one on top times the derivative of the one below over the one below to the square. Okay, so you can see how large these quotients, these derivatives come to be. There is no way around this. Okay, now all I need to do next is calculate the derivative of this function, which is f, as you can see, and the derivative of this function, which is g. So I need f prime of x and g prime of x. I'm gonna do that in yellow over here. So f prime of x. One more time, I'm gonna do it directly. I'm not gonna explain every single thing here. It's going to be 6x to the minus 3 minus 3x to the square. That's f prime of x. And g prime of x is going to be e to the x plus 2x. And I'm done. These are the derivatives of f and g. And I come back to my main problem and I just paste them. H prime of x is going to be e to the x plus x squared times the derivative of all of this, which is this 6x to the minus 3 minus 3x to the square. Then we have a minus, and then this factor, and then the derivative of this, which is this, over this to the square. And I'm just gonna keep it like that. I do not need to raise this binomial to the square. Just keep things like that, okay? Keep things like this. You don't need, for example, you may be thinking, well, can I multiply this binomial times this binomial and this binomial times this binomial? Sure, you can. Yes, that's gonna be time consuming. If you have no purpose on that, don't do it. Okay, if the instruction in the problem just tells you calculate the derivative of h, then if you give this as a result, that is completely and 100% perfect. Maybe if we attempted the products of these two binomials and these two binomials, and then we collected like terms and so on, maybe we can simplify this derivative. By the way, that is not a guarantee. And but the thing is this, I mean, we are done. We are done. It may not be simplified, but we are done. And just keep this derivatives this way unless I tell you to simplify. Okay, so that settles this rule, guys. The rule of the quotient. Memorize the formula as soon as possible. Okay, now let's go to the chain rule. This one is really powerful. So the chain rule, one more time, says this. If you have a function h which can be written in this way, okay, as the composition of f and g, or I don't know if you saw this notation before. Okay, this and this are the same. Then the derivative of h will be f prime evaluated in g of x times g prime of x. This is the rule. This is the chain rule, la regla de la cadena. Okay, let's see how this works. I'm gonna give you 3 or 4 examples. So number one, suppose that we have this function h of x equals x plus 2 to the 5. So it looks like a simple function, right? But a very common mistake when trying to differentiate this function h, which is equal to this, many people are gonna try to do this. They're gonna say, okay, then the derivative of h is gonna be equal to 5. Like we drop down the exponent times this, the binomial, and then we subtract 1 to the exponent. And many people are gonna believe that they're done. Wrong. Completely wrong. Okay? Why? Why is this wrong? Well, because you try to use this form. I mean, these people, these hypothetical people, tried to use this formula. I gave you this formula, guys. If f of x is equal to x to the n, then f prime of x will be equal to n times x to the n minus 1. And this is perfectly valid. You have been using this formula, but you have to pay attention to the way in which formulas in mathematics are written. You need to read things with surgical precision, okay? Like the devil's in the details, guys. What is the difference between this formula and this? Okay, well, the difference is that this formula never told you the following. This is correct. The formula never told you the following. If you have a function f of x equals to x plus a constant c to the n, then the derivative f prime of x is going to be n times x plus c to the n minus 1. Okay, this is a whole new thing. Okay, this is not what this says. The inclusion of that constant makes everything completely different. You don't see no constant here. You see what I mean? So you cannot apply the same rule, even though you may get an idea or an intuition that you could. No, the mere inclusion of that thing, that little number in there, that constant, makes everything completely different, and you cannot apply this rule to this sort of function. Okay, so we are in a big problem, right? Because, I mean, then what can I do? It doesn't seem like we can do anything, right? One thing you could do, and many people resort to this, is the following. These people are gonna expand this binomial. So h of x will be equal to x to the 5 plus 2x to the 4 plus 4x to the 3. You see what I mean? Plus 8 times x to the square plus 16x plus 32. When I expand this binomial to the 5th power, I get all of this. And now, surely you can find the derivative of all of these things, because it's all about finding the derivative of this, the derivative of this, all of these derivatives independently, and then adding them up. Okay? And that would be perfectly right. If you do this, h prime of x is going to be equal to 5x to the 4 plus 8x to the 3 plus 12x to the 2 plus 16x plus 16. That is perfect. This is perfect, guys. But it's way too much work, because you have to expand the binomial to the 5th power. Now, what if instead you had this? Huh? Are you gonna do the same? Clearly not, right? It would be, I mean, impractical, completely impractical. So, what can we do? Okay, here we go. We can apply this rule, the rule of the chain rule, and it works in this way. Okay, this is my original problem. So if you notice, guys, H can be put as a composition of functions. Okay, H can be put in this way. If I say that f of x is equal to x to the 5, and if I say that g of x is equal to x plus 2, okay, I'm creating these two functions, you see, then I can write h of x simply as f evaluated on g. Why am I saying that? Because, okay, um, look, f of x is equal to x to the 5th, okay? So if I evaluate f on g of x, what I'm saying is that I'm evaluating f in this number, right, in x plus 2, because that is g of x. So let's evaluate f in x plus 2. If f of x is equal to x to the 5, then f evaluated in x plus 2 will be equal to x plus 2 to the 5. You see what I mean? It's a composition, and this is in fact h. So basically h of x is going to be equal to x plus 2 to the 5. And it's basically a composition of functions. Okay, so that's the first thing you want to do. You want to write, if possible, you want to write your function as a composition of functions. And in this case, h is equal to f composed with g, where f is this and g is this. Okay, and once you have that, the rest is quite easy. Okay, I'm gonna calculate the derivative of h. H prime of x is equal to f prime evaluated in g of x times g prime of x, according to my chain rule. So all I need to do is calculate the derivative of f and the derivative of g independently. So let's do it. F of x is this. That means that f prime of x is going to be 5x to the 4, and that means that g prime of x is going to be 1. The derivative of this is 1. And I just need to go here and paste it. So h prime of x is going to be equal to f prime evaluated in g of x. And don't make the mistake of just putting this, okay? Don't do this, because this is not the same as this. This is f prime of x, or in other words, the derivative of f evaluated in x. But you need to evaluate in g of x. Okay, that is a little tricky. You're gonna spend some time understanding this. You're gonna evaluate the derivative of f in g of x. What is g of x? It's x plus 2. So I'm gonna do it here. Look, if f prime of x is equal to 5x to the 4, then f prime evaluated in x plus 2 is gonna be equal to 5 times x plus 2 to the 4. You see, it's just a simple evaluation. And this is in fact f prime evaluated in g of x. So let's put this in here. 5 x plus 2 to the 4, and then g prime of x. And this one goes directly from here. G prime of x is equal to 1. So there it is. I'm done. H prime of x is going to be equal to 5x plus 2 to the 4. And in this case, as you can see, it's actually the same as if we have just applied the previous formula, right? Like just drop down the exponent and then subtract 1 from the exponent. But that's just a coincidence. It's just a coincidence. Okay, let's see another example in which this is not going to happen, that coincidence. Number two, suppose that I give you h of x equals 3x to the 4 minus 1 to the let's say 7. Okay, so you have this function. Can I write this function as a composition of two other functions? Yes, I can. One function will be x to the 7, and another function will be 3x to the 4 minus 1. Okay, then I can write h as a composition of f and g in the following way. H of x is equal to f evaluated in g of x. Why do I say that? Why do I say that h can be written in this way? Well, let's take this if you want, and let's analyze over here. Let's analyze it over here. We have f evaluated in g of x. What is f? F of x is equal to x to the 7. So I want to evaluate f not in x, but in g of x. And what is g of x? G of x is all of this. You see? So basically what I'm going to do is evaluate f in g of x, which is this. Okay? And that's going to be equal to 3x to the 4 minus 1 raised to the 7. Let me erase this. Okay? Make any pause whenever you feel like to, and understand what I'm saying. Okay? F evaluated in this will be equal to that same number raised to the 7, right? Because of what f is. So in fact, this is the same as this, which is the same as this. Therefore, h of x is actually the same as f evaluated in g of x, this composition of functions. And once I can write that, once I can write my main function as a composition of two functions, then I can go directly and apply the chain rule. So that means that h prime of x is going to be equal to f prime evaluated in g of x times g prime of x. So let's calculate the derivatives of f and g. We have f here, we have g here, and let's calculate the derivatives first. So f prime of x is going to be equal to 7x to the 6, and g prime of x is going to be equal to 12x to the cube. Okay, now this is f prime of x. F prime evaluated in x is equal to this, and that means that f prime evaluated in g of x, which is what I need from here, is going to be equal to 7 times g of x to the 6, right? But what is g of x? G of x is all of this thing, 3x to the 4 minus 1. So I might as well erase this thing and input such binomial, 3x to the 4 minus 1. 3x to the 4 minus 1. And this is, guys, f prime evaluated in g of x, which is what we have in here. You see? And now, g prime of x, I already have it, which is this thing. And that's it. This result and this result are the ones appearing in here. And I just paste them. So f prime evaluated in g of x is all of this thing. 7 times 3x to the 4 minus 1 to the 6 times g prime of x, which is 12x to the cube. So as you can see, now we have a different thing. We have a more complex thing. And again, you can just keep it like this. If you want to multiply this 12 times this coefficient, go ahead. but you can just leave it like that, and that would be perfect. Okay, now compare this result to uh, a poorly applied formula, which look at this, and so people are going to say, well, h prime of x is going to be simply, we drop down the exponent 7, we write the same binomial 3x to the 4 minus 1, and then we subtract 1 from the exponent. Okay, if you try to do this, that would be incorrect, because compare this to this. Okay, you do have the first part. You see, all of this is this, but you would be missing this little thing in here. You see, so be careful, be very careful. Let me give you another example. What about this? Number 3, h of x is equal to cosine of 3x squared minus 1. Okay, again, we have this function. It looks a little complex because it's not just cosine of x, something simple. No, it's cosine of this thing, which is more complex than just x. Okay, so I may want to put h as a composition of functions. That in yellow. So I'm gonna use this function f of x equals cosine of x, and g of x equals this internal function 3x squared minus 1. If I define f and g in this way, then I can write h as a composition of functions. H of x is going to be equal to f evaluated in g of x. Make sure that h of x is going to be equal to this. One more time. If f of x is equal to cosine of x, then f evaluated in g of x is going to be equal to cosine evaluated in g of x. I'm going to go very little by little. And that means that f evaluated in g of x is going to be equal to the cosine of g of x, which is all of this, 3x squared minus 1. So f of g of x is equal to cosine of 3x squared minus 1. You see? And what is this, guys? This is in fact h. Can you see? H is equal to this. Look. So that's why I'm saying that f evaluated in g of x, or f of g of x, is equal to h of x. Or the other way around. H of x is equal to f of g of x, just as I claimed over here. Writing a function as a composition of functions can be tricky. You have to have experience, okay? You have to work your way up from very simple cases and then get enough practice so that you are able to go like, okay, h is the composition of two functions, one of which has to be this and the other has to be this. There really is no recipe, guys, for me to tell you how to compose functions. You have to just try. Okay, so now this was just a little explanation. We don't need it anymore. So let's ignore it. And now I'm ready. Once I have put my function h as a composition of functions, I'm ready to write its derivative. Its derivative, h prime of x, is going to be equal to f prime evaluated in g of x times g prime of x. So I need to calculate f prime and g prime, or the derivative of f and the derivative of g. That's very simple. We have f in here. F prime of x will be minus sine of x. G prime of x will be 6x, right? But remember, we're not going to use directly f prime of x. What we need is f prime of g of x. So that means that f prime evaluated in g of x is going to be equal to minus sine of g of x. And that means minus sine of 3x squared minus 1, because this is in fact g of x. Look, so I already have f prime of g of x is equal to all of this. And that's what I need to put in there. Minus sine of 3x squared minus 1. And I can enclose all of this. All of this thing is f prime of g of x. And the other one is simpler. Just go look for g prime of x, which is 6x, and plug it. Paste it. There it is, guys. This is my full answer. Nothing else remains to be done. So that's how the chain rule works, guys. You need to write your function that you're trying to differentiate as the composition of two functions. You have to create function f and function g, or any other name like I told you, and write h as f evaluated in g of x, also known as f of g of x. And that can be a little tricky. You need to experiment a lot. Don't get frustrated if you don't get it at once. Just practice, practice, practice. Okay, guys, so this concludes the fourth lesson, 5.4 rules for differentiation. And this is the last topic that will appear in the exam. And that's it.